Good morning, students. Students, as you all know, we have started with our lesson number 4, Effects of Electric Current from Science 1. And today we shall be learning a new topic. So let's begin. Today we will learn about alternating current. Alternating current, which is also written as AC, and direct current or DC. In an alternating current, the direction of the current is constantly swapping back and forth. So, the charge flow in one direction, then in other direction, and then back again. We get this alternating current when we use the alternating potential difference or alternating voltage. So one fluctuate brings positive and negative. We can see this if we measure these potential difference or current over time. They constantly fluctuate between negative and positive in a circular loop. This means that the direction in which the charge is flowing will constantly swapping back and forth. Even if we carry all the main supply electricity, which is the electricity that comes from plug sockets and powers from computer and so on, is AC, and specifically main supply is 50 Hz and around 240 volts, which means that in a graph the potential difference fluctuates from positive 240 volts to negative 240 volts and back again 50 times per second. And the current will also fluctuate at that same rate. Understood, children? Now, direct current or DC, on the other hand, is produced by the direct potential difference, which is either positive or negative. The entire time to charge is always flowing in the same direction. We find direct current in the cells and batteries, like those in your phones or calculators. So, have you understood, children, what is alternating current and what is direct current? Yes. Now moving to the next one. Electric generators. Now we have performed experiments based on electromagnetic induction. In these experiments, the magnitude of the induced current was very small, but the principle which we learnt from these experiments can be harnessed for use of mankind to produce large current. Here, mechanical energy is used to rotate the current carrying coil placed in a magnetic field around an axle, thereby producing electricity. Now there are two types of electric generators, AC generator and DC generator. So AC generator is in which the mechanical energy is converted to electrical energy in the form of alternating current. Whereas in DC generator, mechanical energy is converted into electrical energy in the form of direct current. So, let us first learn about the construction and working about AC generator first. The main components of AC generator are a copper coil ABCD, strong magnet, conducting rings and carbon brushes. A copper coil ABCD of rectangular shape is kept between magnets. The two ends of the coil are connected to the conducting rings R1 and R2 by a carbon brushes. Both the rings are fixed to the axle. There is a resistive coating in between the ring and the axle. The axle is rotated with the help of a machine from outside. When the axle is rotated, note that here we have mentioned the axle to be rotated manually. Then the coil ABCD starts rotating in the magnetic field. Two stationary carbon brushes B1 and B2 are used to make electric contact with conductive rings. These brushes are connected to a galvanometer, which shows the direction of current in the circuit. Upon rotating the axle, branch A and B goes up and branch CD goes down. That is, coil ABCD rotates clockwise. According to Fleming's right-hand rule, the electric current is produced in the branches A, B, C, D in the direction A to B and C to D. Thus, the current flows in the direction of A, B, C, D. In the external circuit, the current flows from B2 to B1 through galvanometer. Thus, the galvanometer shows the deflection on one side. Understood, children? So, if a coil consisting many more turns is used, the current increases several times of magnitude. After half rotation, the branch AB takes the place of branch CD and the branch CD takes the position of branch AB. The induced current then goes as DCBA and branch BA is always in contact with brush B1. Branch DC is always in contact with brush B2. And in the external circuit, current flows from B1 to B2. This repeats every half rotation and alternating current is produced. This is what is called as AC generator. There is one more type of generator as discussed earlier, known as DC generator. So what will be required to make a DC generator? Come, let us discuss about it. Let us first draw the diagram of DC generator. The main component of DC generator are a copper coil ABCD, strong magnets, split rings, carbon brushes and bulb. DC does not change the direction in the external circuit. To achieve this, a split ring is fixed on the axle like a fixed ring, shown in case of electric motors. A bulb is connected across the brushes to indicate the output current. When the coil rotates in the magnetic field, a current is induced in the coil. As the coil rotates, the split rings attached to the end of the coil also rotates. The brushes B1 and B2 make electric contact with the split ring. Let the coil rotate in clockwise direction such that branches AB is moving downwards while the branch CD will move upwards. So the current induced in the coil is given by Fleming's right hand rule. Here the induced current in branch AB is outwards while in branch CD it is inwards. Hence, in the circuit, the current flows from brush B1 to brush B2. When the coil AB rotates, it becomes right angles to the magnetic field. The contact of the ring R1 with the brush B1 breaks. Similarly, the contacts of the ring R2 with B2 breaks. The coil continues to move due to inertia and the branch AB comes in front of North Pole. Now the ring R1 comes into contact with brush B2 and R2 with B1. The direction of the induced current in CD will be in outward direction while it is in inwards direction in branch AB. The current in the outer circuit is from B1 to B2 in this half cycle also. Hence, the current in the external circuit flows in only one direction and in both the half cycle. This process continues and a direct current is obtained. I hope you find it easy, children, to understand. So, let's check the summary. Alternating current AC. Alternating current is a current that changes direction in time. If the high and low voltage terminal switch locations periodically, the current will flow back and forth in the circuit. This is called as alternating current or AC. Direct current. When the current in a circuit has a constant magnitude and direction, the current is called direct current. Because the potential difference between the terminals of a battery is constant, the battery produces direct current. The battery is known as the source of EMF, that is electromotive force. Electric generator. An electric generator consists of a magnet which creates a magnetic field and a loop of wire which rotates in the magnetic field. As the wire rotates in the magnetic field, the changing strength of the magnetic field through the wire produces a force which drives the electric charges around the wire. As the loop spins, the direction of the force and current changes. The changing direction of the force after every 180 degrees of rotation gives alternating current. Let's see what is AC generator. It is also called dynamo or alternator. It converts one form of energy into another form, that is from mechanical to electrical energy. It operates through interaction between a magnetic field and coil, and it works on the principle of electromagnetic induction. Let's see the next, that is the DC generator. DC generator is an electric generator that converts alternating current generator into unidirectional or direct current output. An AC current generator may be converted to DC current generator in a couple of ways. By using split ring commutator instead of slip rings. The split ring commutator is mounted on the armature shaft but is insulated from it. The commutator reverses the connection of the coil to the external circuit each time the current reverses. Thus, DC output is achieved from AC generator. So children, with this we have finished our today's lecture. I hope I have made myself clear and you all must have understood today's topic. I request you children to please read the lesson after watching this video attentively to make your concept clear. So children, we shall see you in the next lecture with a new topic. Till then, thank you very much. Bye-bye children. Take care.